Good day, my viewers. In today's video, we'll be looking at elimination of arbitrary constants. Now, I will be solving two examples in this class. Then, maybe after the class, I will be giving out an assignment to all my viewers to solve. Now, from question number 1, we are asked to eliminate the arbitrary function f, given that u is equal to f bracket x squared plus y squared. Now, in example 2, we are asked to eliminate the arbitrary constants f and g, given that u is equal to f into y plus 2x plus xg bracket y plus 2x. So we're going to be starting with the first one. Now, in the first one, we have a single arbitrary constant, that is f, to eliminate. While in the second question, we have two arbitrary constants, f and g. Now, elimination of arbitrary constants is very simple and easy to do. The only thing you need to do is nothing but to understand the steps and the procedures that are involved. Now, let's start with example 1. Example 1. The only thing you have to do is nothing but to understand the procedures and the steps in solving it. Now, from the first question, they say we should eliminate the arbitrary function f, given that u is equals to f into x squared plus y squared. To eliminate the arbitrary constant, u is equals to f into x squared plus y squared. Now, the first thing we have to do is this. Since we want to eliminate this arbitrary function f, we are going to differentiate this given function partially with respect to x once, and we are going to differentiate this function again partially with respect to y once. The reason why we are differentiating with respect to x once and with respect to y once is because we have only a single arbitrary function. When you have two arbitrary functions, you are going to differentiate twice partially. You're going to differentiate twice partially. So for this now, we start with use of x. Now, this is function in a function. This is a function in a function. So when we differentiate f with respect to x, f is not x, so we have f prime. Then into, when we differentiate x squared, remember that this x squared plus y squared is inside f. I can still write this as f. I can still write it as f, whereby f contains a function inside of it, that is x squared plus y squared. So when we differentiate f, we get f prime. Then I have to differentiate the function it has inside, which is x squared plus y squared. So when I differentiate x squared, I get to x. When I differentiate y squared, know that since we are differentiating partially, anything that is not x is automatically a constant. So when I differentiate y, I will get to what? 0. So this will give me 2x f prime. And this is the same thing as 2x f prime bracket x squared plus y squared. Remember that this function contains this. This is inside of it. Remember that I said that this is the same thing as this. So this now contains x squared plus y squared inside of it. So this f prime also contains x squared plus y squared inside of it. You can put it this way or you put it this way. It is still the same thing. Now let's get use of y. You still go to the function. Know that this is function into a function. This is inside of this. This function contains this inside of it. So when I differentiate f function with respect to y, I'll get f prime into, now I will differentiate the inside function. If I differentiate x squared with respect to y, I'll get 0. If I differentiate y squared with respect to y, I'll get 2y. So if I expand, I'm going to obtain 2y f prime. So this is something as 2y f prime into x squared plus what? Y squared. Don't forget my explanation. Don't forget my explanation. This is function into a function. Function into a function. This is contained inside of this. So for me to touch this, first of all, I will hit this function first. So since this function is never x, if I touch it, I'll get f prime. The next thing I have to do is to differentiate whatever thing that is inside of it. If I differentiate x here, x squared, I'll get to x. If I differentiate y squared here, since y squared is never x, I'll get 0. So you take whatever thing you have. Likewise this. Now, looking at ux now, my ux now is equals to 2xf prime. And my uy is equals to 2yf prime. Now, what can I do to this and this from this arbitrary constant to be eliminated? Now, looking at this, this is 2xf prime and this is 2yf prime. This is 2xf prime and this is 2yf prime. If I should multiply this by y and multiply this one by x, it seems that both of them will look alike. Remember, this is 2xf prime, 2yf prime. Okay, let me multiply this by x and multiply this by y and see what I will have. So multiply ux by x and multiply uy by multiply ux by y and multiply uy by x. Look at the reason why I'm doing that. I want to get to a point whereby this arbitrary constant will be eliminated. So since this one has y and this one has x, this one has 2, they have 2, good. They have f prime. This one has x and this one has y. So let me give this one x and give this one y, so that both of them will be the same thing, so that I can eliminate the arbitrary constant. That's what I'm trying to do. So if I multiply ux by y, so what I'm going to have now will be y ux is equals to 2xy f prime, and this one will be x uy equals to 2xy f prime. Remember, multiply ux by y, so I multiply y times this will give me this, y times this. Remember, anything you do for this side, you should also do it for this side. So I have this, multiply uy by x, so anything you do for this side, do it this side. S times this, s times this. So looking at it now, you find out that this is 2xy f prime, this is also 2xy f prime, it's the same thing. So it implies that 2xy f prime minus 2xy f prime is equals to what? 0. So it implies that the arbitrary constant has been what? Eliminated. So therefore, yux minus xuy is equals to what? 0. Since this minus this is 0, it implies that this minus this is also what? 0. So from this now, the arbitrary constant has been eliminated. So let us look at example number 2. They say that we should eliminate the arbitrary function f, given that u is equals to, okay, eliminate the arbitrary constants f and g. So we have two arbitrary constants here to eliminate, given that 2 is equals to f into y plus 2x plus